Welcome back with another video on TryHackMe.com. This is Zaheen Nazir and we are doing DevSecOps. So before we proceed, let's see our overall progress here. As you can see, we are pretty behind because this is August 1st and we wanted to finish on 31st. I think in next 2 days we'll be able to finish it. Certificate progress is 95% and we don't have any other badge to achieve. We are on the very last. In previous videos, we covered the on-premises practical where we got flag 1, flag 2, 3 and 4 in 2 separate videos, and now we're gonna resume our cloud-based IaC where we had left it. So we already covered from task 1 to task 3 in one of the videos, just check it out. And now we're gonna cover the next 2 tasks at least, next 2 to 3 tasks at least, and then if possible, in the last video, we'll cover the Terraform versus CloudFormation and the rest of the task 8, task 9. Okay, so let's get started. Task 4 is Terraform workflow. Understanding the Terraform workflow generally follows 4 steps: write, initialize, plan, and apply. Well, should plan first and then write, initialize, and apply. What do you say, guys? Okay, we'll continue. To better understand this workflow, how it can benefit DevSecOps engineers while provisioning of infrastructure, let's consider an infrastructure at different points in the development. When dealing with infrastructure provisioning, we tend to have different problems at different stages. To illustrate this, let's consider the Terraform workflow at 3 points in time: day 1, day 2, and day n. Day 1 is the infrastructure does not exist yet and it needs to be provisioned from scratch. Day 2 plus the infrastructure exists but some changes needs to be made. Day n, an undefined point in time when you no longer need this infrastructure. Okay, so this is how it will be. Day 1, let's take a look at what the Terraform workflow would look like. On day 1 of the infrastructure provisioning, you have an empty environment with no infrastructure set up and need to define and provision this infrastructure using Terraform. You would follow this workflow, right? In this part of the workflow, you would define the desired state of your infrastructure in Terraform configuration file. As discussed in previous task, these configuration files are used to define the desired components, and these components can reference each other if they have a relation. Okay, initialize. The next part of the workflow is to initialize. The init command prepares your workspace, the working directory where your Terraform configuration files are. So Terraform can apply your changes. This preparation includes things like downloading dependencies. For example, if your configuration file defines AWS as the provider, during the initialization, the Terraform will download the AWS provider plugin. This is done using the following command: Terraform init. Plan. After initializing your workspace, you should now plan your changes. The planning stage considers that what infrastructure is present currently. With it being day 1, there will be no infrastructure present versus the desired state, and prepares a plan of action, which if applied will make it so infrastructure matches the desired state. It produces this execution plan and will tell the user what components will be added and destroyed in the process. This is done using the command Terraform plan. Okay, so once we initialize, it will download the provider. Once we do the Terraform plan, it will basically plan the execution to achieve the desired state. Okay, apply actions the steps detailed in the plan required to take the infrastructure from current state to desired state. Okay, Terraform works out which order these infrastructure resources should be created. In our example from previous tasks, we defined 2 resources, a VPC and a security group. Since the security group references the VPC and is therefore depends on it, VPC is virtual private control or network or something like that. Okay, and security group, since the security group references the VPC and therefore depends on it, Terraform would create the VPC first. This is done using the command Terraform apply. Okay. Okay, so we have right here, we have initialize, we have plan, and we have apply. As you can see, writing something, and then we are initializing, we are saying, okay, everything is there, we are planning it, what we need to do exactly, which kind of similar to right? But this is different as we started it, and then we apply, and we will have robots. Day two means any day after the infrastructure has been provisioned. What will be the workflow look like when making changes to an existing infrastructure? Say for instance, you want to add a component to your infrastructure. Initialize. Terraform initialize should be first command run after making any changes to an infrastructure configuration. It will initialize the workspace just like when creating the infra from scratch. Plan. Terraform plan is not required, but it's best practice, especially in an already existing infrastructure. The execution plan generated by the plan command will show you exactly what is being removed or added to the infrastructure. This can catch any misconfigurations before they are applied and break things. The plan will assess the existing infrastructure. In this case, note that the existing components match the desired state, so no changes need to be made, but the additional component has not been created yet and will need to be created to match the desired state, so will be listed as a resource that needs to be added. Okay, awesome. Apply. Again, Terraform will provision the infrastructure changes defined using the execution plan made during the plan phase. Note that if you skip the planning phase, Terraform will automatically create an execution plan as if you had, and will ask you to approve the plan before execution. The state file will then be updated to reflect that the current state now matches the desired state as the additional component has been added provisioned. Okay, so apply में वो क्या करेगा? Basically, it will go and try to execute, make the updates to the infrastructure itself. All right. Day end. Day end denotes a day in the future when the infrastructure is no longer needed. Maybe it was just a test environment, or the application it supports has been shelved. Now that this infrastructure is no longer needed, all this is required is to destroy it. Destroy. Running the Terraform destroy command will take care of this functionality. Functionally, the destroy command is quite similar to the apply command in that it takes a plan, a destroy plan, which transforms making or which Terraform makes no running on running this command and compare it to what infrastructure currently exists and actions the plan instead of provisioning, deprovisioning resources changes. It tear down all resources. So Terraform destroy will tear down all resources. So it will go from initialize to destroy. Okay. What command would you run to action the steps outlined to take your infrastructure from desired state to actual state? Desired state to actual state. I think I will go with initialize. No, right? I would define the desired state and from current state to desired state. So we'll go with the apply, Terraform apply. Here it is. Desired state to actual state. From actual state to desired state, I think they meant here. The question is a little bit wrong here. What command would you run to prepare your workspace? Terraform init. Alright. What command when run would provide you with a series of actions that would be required to take your infrastructure from desired state to the action state? I think it is plan. Alright, we are good. Let's go to task 5. Okay, CloudFormation 101, CloudFormation overview. CloudFormation is an Amazon Web Services AWS IaC tool for automated provision and resource management. Instead of manually configuring resources through the AWS Management Console or using the AWS command line interface, you can use CloudFormation template to describe your infrastructure in a declarative manner. Okay. Declarative infrastructure as code. With CloudFormation, you express the desired state of your infrastructure using a JSON or YAML template. This template defines the resources, their configurations, and the relationships between them. CloudFormation provides and manages these resources, making managing and replicating your infrastructure easier. Templates and stacks. A CloudFormation template is a text file that serves as a blueprint for your infrastructure. It contains sections that describe various AWS resources like EC2 instances, S3 bucket, and more. When you use a template to create resources, it forms a CloudFormation stack. Stacks are fundamental units of CloudFormation, and they represent a collection of AWS resources that are created and updated and deleted together. Okay. Templates and stacks. Okay, examples are here. AWS template format version 20100909 is very old version. Description is simple CloudFormation template. We have resource section where the AWS resources are defined. Give me a second, guys. My EC2 instance, logical name of the resource, type is AWS : EC2 : instance, type of the AWS resource being created. Okay, properties are here. Image ID is AMI, and then the image ID. Instance is T2 micro. Okay, and the key name is, this is the SSH key pair for accessing the instance. So we put everything in template, even the SSH keys here. Okay. My S3 bucket, another resource we need to create. Property bucket name is this one. So it's an object bucket, right? You can store anything there. Output section to define the outputs for the template. EC2 instance ID, logical name for the output. Description ID of the EC2 instance. Value, we are doing ref. And if it is not null, I think, then we just give the value of my EC2 instance, which is from here. Reference to the EC2 instance resources. Okay. AWS template format version. This specifies the CloudFormation template version. Description that provides a brief description of the template. Resources. This section defines the AWS resources to be created, such as EC2 instances or S3 bucket. Each resource has a logical name. My EC2 instance, my S3 bucket type indicates the AWS resource type. Properties hold configuration settings for the resource. Outputs. This section defines the output values displayed after creating the stack. Logical name, description, and reference to a resource using ref. Okay, so question, exclamation, and then the ref itself. It's not similar to the O programming, but to reference the object. CloudFormation Designer is a service for visually creating and validating these templates. Read more about it. Let's see what we have here. So, using the old AWS Formation Designer to create templates. Okay, so there is an old one and there is a new one as well. So this is JSON, this is YAML, and this is the way you create the resources. Awesome. I like it, man. I like it. Usually I'm a visual learner, so it is the preferred way to see what is going on, what you are creating within Amazon. All right, we are back. CloudFormation architecture, sure. Similar to Terraform, CloudFormation follows a workflow for provisioning and management. To better understand the workflow, we need to understand the inner workings of the CloudFormation and its architecture, sure. Main and worker architecture. CloudFormation employs a main worker architecture. The main, typically a CloudFormation service running in AWS, interprets and processes the CloudFormation template. It manages the overall stack creation, update, or deletion orchestration. Okay, the worker nodes distributed across AWS regions are responsible for carrying out the actual provisioning of the resources. Okay, so we have template processing flow. We have a user. We define, create, or use an existing template, save locally or in S3 bucket, and then use AWS Formation to create a stack based on your template, and it construct and configures your stack resources. So stack is basically like you tell us, okay, these are the things I need to buy, and once you apply the template itself, it will create the stack on the AWS using the CloudFormation. So this is the simplest explanation that I can give. Template submission. Users submit a CloudFormation template written in JSON or YAML to the CloudFormation service. The template specifies the desired AWS resources and their configuration. This can be stored in an S3 bucket, for example. Sure. Template validation. The CloudFormation service validates the submitted template to ensure its syntax is correct and it follows AWS resource specifications. Okay. Processing by main node. What is that? The main node processes the template, creating a set of instructions for resource provisioning. It determines the order in which resources should be created based on the dependencies. Okay. Resource provisioning. The main node communicates with worker nodes distributed across different AWS regions. Worker nodes carry out the actual provisioning of the resources stated by the instructions provided by the main. Stack creation and update. The resources are created or updated in the specified order, forming a stack. The stack represents the complete set of provisioned resources. Okay, so stack itself will represent the complete set of provisioned resources. Once it is provisioned, we call it a stack. Okay, event-driven model. CloudFormation operates on an event-driven model. Events are generated during the stack creation, update, and deletion process. The CloudFormation logs these events. Users can monitor these events to track the progress of stack operations or identify any issues. Rollback and rollback triggers. If an error occurs during the stack creation or update process, CloudFormation can automatically trigger a rollback, reverting the stack to its previous state. A rollback trigger can be defined in the template to specify conditions under which a rollback should occur. Okay. Cross-stack references. CloudFormation supports cross-stack references, allowing resources from one stack to reference to resources in another. This is useful for managing complex applications and dependencies that span multiple stacks. Understanding the architecture of CloudFormation provides insights into how the service efficiently manages the orchestration and provisioning of AWS resources, ensuring a reliable and consistent infrastructure deployment process. Okay, awesome. What is generated during stack creation? What is generated during stack creation? Resources. CloudFormation create a stack based on your template, and it construct and configure your stack resources. I don't know, it is resources or what? Resource? No, it's not resource. What is created? What is generated? Sorry, what is generated? Maybe it is template. Resources are created or updated. Okay, farming stack represent the complete set of provisioned resource. I don't know what to put here. Event model generates during events are generated. Events? Okay, it was events. Can you define rollback trigger in a template? Yes. What allows you to refer to resources in another stack? Cross stack references. It was easy. All right. We are good. Let's move on to the task 6. All right. It's theory as well. Some of you are moving at a fast pace. CloudFormation configuration and use cases. Configuration and concept. Template structure. CloudFormation template consists of key sections. AWS template format version. We already know about this. Specify the AWS CloudFormation template version. Description describes the template. Parameters. You can input custom values when creating or updating stack. Resources define the AWS resources to be created and or managed. Outputs describes the values that can be queried once the stack is created or updated. Okay. Intrinsic function. What does that mean even? CloudFormation template supports intrinsic functions which help you perform operations. Example of intrinsic function are referencing resources, performing calculation, and conditionally include resources. Okay, so intrinsic function, we have resource, we have my instance type is here, properties, image ID, and instance type, output instance ID. We know how to reference this. Where is the function itself? Public DNS is value get attribute my instance dot public DNS name. Substitute string is value substitute hello, and then we are printing some my instance. My instance is here, so we are printing the value here. Function ref refers to the value of specified resources. Where is function ref? I don't know function ref, but we see only ref here. Okay, so without, you can mention them without mentioning the fun and the other thing by just mentioning this one exclamation. Gets the value of attribute from the resource in the template, and sub is perform the string substitution. Okay, got it. Resource dependencies. Resources in the CloudFormation can have dependency on each other. For example, the EC2 instance might depend on a VPC, virtual private cloud. So it's virtual private cloud and not the network, right? But it will be isolated, right? Private cloud inside the cloud environment. A VPC is granted to user the cloud provider so that their resources are not accessible by other resources, other user in the same public cloud. Okay. Being creating first, CloudFormation automatically handles the order of resource creation and updates based on these dependencies. Chain sets. Before making changes to a stack, CloudFormation lets you preview the changes using a chain set feature. Okay, this helps in understanding the impact of the modification before they are applied. So before the modification is applied, we will get to see a preview in chain set. Okay, use cases. There are many use cases for resource provisioning and management in AWS. Here are some of the examples. Infrastructure provisioning and management. CloudFormation simplifies the process of creating and managing AWS resources. It ensures consistency and repeatability in infrastructure deployments, reducing the risk of the configuration errors. Awesome. We know that now. Application lifecycle management. CloudFormation is commonly used to manage the entire lifecycle of the application. This includes provisioning resources, deploying application code, handling updates or rollbacks. Awesome. Multi-environment deployment. Deploying the same infrastructure across multiple environment dev test production is often necessary. CloudFormation allows you to use the same template with different parameter values for each environment. All right. Resource scaling. As your application or workload grows, CloudFormation enables you to quickly scale your infrastructure by modifying this template or using auto scaling capabilities. Okay, CloudFormation provides a robust and scalable way to manage AWS resources through code, offering benefits in terms of automation, consistency, and collaboration in the cloud infrastructure setup and maintenance. Okay. Does CloudFormation support intrinsic function? Yeah, you can basically do that. What feature helps you understand the impact of modification before they are applied? These are change sets. Change sets. Awesome. So we still have 5 minutes to go. So let's continue with our task 7. Terraform versus CloudFormation. Terraform versus CloudFormation. Okay. CloudFormation vendor log. As we know, it will be only working with AWS. AWS for CloudFormation is tightly integrated with AWS services, making it natural choice for AWS-centric environments. Native integration, seamless integration with other AWS services, providing direct resource references and a unified management experience. Service coverage provides comprehensive coverage of AWS services, often including support for new services shortly after release. Learning curve. Learning CloudFormation may be easier for those familiar with AWS services. Awesome. It is easier if you are already working with AWS, right? So Terraform. What is Terraform? Terraform is cloud agnostic. You can use it on any cloud. Terraform is cloud agnostic, supporting multiple cloud providers, including AWS, Azure Cloud, Google Cloud, and more. This makes it a versatile choice for hybrid or multi-cloud deployment. I think this is what we should use, so that even if the cloud provider is changed, your skill set is not changed. You will be doing the same thing, and you will be learning just the thing to fill up the gaps for that particular environment. So I think the better way is to go with Terraform. Community and modules. This has a large and active community, and using modules allows for reusable and shareable code. This is very good. State management. Terraform uses a state file to track the current state of the infrastructure, providing a clear view of the deployed resources. Language flexibility. The HashiCorp configuration language HCL is what Terraform is designed for readability and is more flexible than JSON and YAML. This is a big statement. All right, good. We'll use it and we'll get to know what is going on there. Use cases. Terraform use cases. Multi-cloud environments. Scenario: a company utilizes infrastructure with multi-cloud providers such as AWS, Azure, and GCP. Reason for Terraform has provider for various cloud platforms, making it easier to manage multi-cloud environments. Yes, a single Terraform configuration can span different cloud providers, allowing consistent infrastructure as a code across entire infrastructure landscape. This is very good. Community modules and providers. Scenarios: an organization heavily relies on community contributed modules and providers to enhance infrastructure provisioning. Reason for Terraform: Terraform has a vibrant community that contributes reusable modules and providers for a wide range of services and platforms. Leveraging community driven content can significantly speed up the development process and provides best practices adopted by a broader audience, and also can bring some security issues as well. AWS CloudFormation use cases. Deep AWS integration. Scenario: an enterprise infrastructure is predominantly AWS centric, and the team is deeply invested in AWS specific services and features. Reason for CloudFormation: AWS CloudFormation provides native integration with AWS services, making it well suited for managing AWS specific resources. Okay. Features like CloudFormation stack sets and change sets enhance the management of AWS specific resources and deployment. Yeah, this is a very nice feature. We can see what the changes will be in the change set before even they are applied on the infrastructure. Managed service integration. Scenario: an organization heavily utilizes AWS managed services such as AWS Elastic Beanstalk or AWS Ops work. Reason for CloudFormation: AWS CloudFormation integrates seamlessly with AWS managed services, offering simplified provisioning and management of these services. CloudFormation provides specific resource types for many AWS managed services, allowing for a higher level of abstraction in the template. I think higher level of abstraction basically provided by Terraform. But yes, this is also true in the context of CloudFormation. Okay, is CloudFormation cloud agnostic? Never. Which IaC tool has deeper AWS integration? IaC tool. It's CloudFormation. CloudFormation. I need to put an N at the end. Yes. Which IaC tool has accessible community-driven module. Terraform. Is this right spelling? Terraform. Okay, so it is Terraform. Awesome. So 30 minutes parts. Once we come back, we will take care of these tasks, and that will be the end of DevSecOps. Thank you guys for joining me on this journey. I hope you enjoyed this journey. It is a long way coming. We did it for I think 1 month or more to reach to that level. I think more than 1 month. I haven't calculated the days that we are doing this, but we are consistent. We are doing every day. We started, but in the start we missed few days, and that's why we are behind. But now we can say that we are on time, almost on time, and we are making a good practice on TryHackMe.com. So I also want to run a poll to what to do after this DevSecOps, either to go with the SOC 1 or penetration testing, junior penetration path, or the security engineering path. So let me know, guys. I'll put the poll in. I will try to put it on YouTube if there is a way to do that. Otherwise, I will put it on the X. Okay, X platform. So thank you guys. If you haven't subscribed, please subscribe. If you like the video, please give the thumbs up. If you have any suggestion, please put it in the comments section below the video, and I will see you in the next video. Thank you very much. Bye.